Hello everyone, my name is David Connolly, and in this video I just want to outline the value of the heat sector, which is something that we often see as underestimated in a lot of the discussions we have around Heat Roadmap Europe. And I think the first thing I want to point out is that it's not so much the size of the heat sector that we want to discuss I want to discuss in this video, it's the value of it. So in a previous video I outlined this diagram looking at the demands in 2010 across Europe, highlighting how the heat demand in buildings is actually more than the entire electricity demand in Europe and the heat demand in industry in that year. And also, if we look at a typical house in Europe, we can also see that the heat demands are much bigger than electricity, with a typical house consuming around 5 megawatt hours of electricity each year, but around 15 megawatt hours of heating each year. Even the Commission themselves are acknowledging this more and more. I just took a quick extract from the recently published Heating and Cooling Strategy, where the first sentence on the website for that strategy says that heating and cooling in buildings and industry accounts for half of the EU's energy consumption. Therefore, just highlighting how it's not so much the demand that isn't appreciated right now. In my view, it's the value. Because what I want to ask is, if we all acknowledge that this is a big sector and accounts for a big demand, the key question is, does this size matter? Is it actually worth something? And a lot of the time I think people misunderstand just how valuable heating is. So to demonstrate that, I'm going to take a quick example here to show you how the cost of producing heat is actually more than the cost of producing electricity. And to do that, I'm going to take the cost of producing electricity from a coal-fired power station versus the cost of producing heat from a gas boiler. And I divided these two components into three key parts. The coal-fired power station has to pay for, of course, the fuel, the coal that it consumes. It has to pay for the plant to build it, and it has to then produce electricity using the plant and using the fuel. Secondly, the gas boiler has to use some fuel, such as gas in this case. Then it has to pay for the boiler, which actually burns the gas. And between those two, the boiler and the gas, you then produce some heat. So what I'm doing is I'm adding up the cost of the fuel and the plant and dividing it by the total amount of energy that's produced. Also, what I'm doing is I'm looking at these costs on an annual basis. So for example, for the coal-fired power station, I'm taking a 700 megawatt plant, which is a very big power station. I'm looking at the amount of fuel that they typically consume in a year for this size of a power station. I'm looking at how much money it costs to build the plant on an annual basis. So in other words, I've annualized these costs, so I've divided the total investment by the lifetime and then added some financing costs and so on, and come up with the number of 113 euro, a million euro per year to build this plant. And then I've divided these total costs by the total electricity typically produced in a year to come to a levelized cost of around 40 euros per megawatt hour for this coal-fired power station. I've done the exact same thing with the gas boiler. Of course, the gas boiler is on a much lower scale because a typical person would spend maybe 500-600 euro on gas. This is using socioeconomic costs, which I'll display in a second. Then also building the boiler. Of course, the boiler itself, I've assumed 4,000 euro, but divided by the lifetime of 22 years means that you're only paying maybe 385 euro per year, and divided this total price by the heat typically produced in 1 year, and this is hot water and space heating. So the price of producing heat is around 60 euros per megawatt hour. So straight away, what I want to demonstrate is that we today are actually it costs us more to produce a unit of heat than it does to produce a unit of electricity. So it's not just about the fact that the heat demand is big. We actually pay a lot of money to produce heat today. So, and of course, I want to put this in context because this is just for one scenario, and it's the socioeconomic cost of producing electricity and heat for just one scenario. And I just want to add a few disclaimers because putting numbers out there like this can often lead to some misunderstandings. So the first thing I want to explain what I mean by socioeconomic cost. And what I mean by that is I haven't included profit, VAT, or taxes in my calculation. So this gives you a quick overview of the average price of electricity in Europe in the second half of 2015. And what you can see is that they divide the price into three key parts: VAT, so value added tax, taxes and levies, and then the base price. And as you can see, for a lot of countries, the taxes and levies and VAT can make up a lot of the overall price. Taking Denmark as a great example as the most expensive country when it comes to electricity prices, but as you can see, over half of that price is made up of VAT and taxes and levies, with the base price only representing around a third of the overall price. However, within this base price is also included the profits that the companies need to earn to sell the electricity, which is something I have excluded, and which is why I refer to mine as a socio-economic cost, because it simply reflects the cost of producing the energy, not the cost plus the profit and risk and everything like that that the companies selling it have to take into account. The second thing that I want to highlight is that for electricity, in my case, I've only included production price. So I've only included the price of producing electricity at the power station and not the price of delivering that electricity to the final user via the electricity grid. So that's just another important caveat to remember. And this is also why I want to move to a disclaimer number 2, because looking at these numbers, you might conclude that electricity is a very cheap way to supply heat, but that's actually not the case in most circumstances. Because again, I've only looked at the fuel, the power station, and the total electricity delivered. I haven't looked at the price of building the grid or the price of building the electric heater, and that will change this picture dramatically. So it's just to say that don't conclude from this brief comparison that electricity is a cheap way to supply heat. And also remember, I'm looking at electricity production versus heat production. I'm not taking into account in the electricity sector for the grid to deliver the heat to the final user. Then also from the gas boiler point of view, and even for the power station also to a lesser degree, I've only considered one scenario here, but it's very important to remember that these prices can vary significantly. And to illustrate that, I've just taken the gas price over the last 15 years or so across America, Europe, and Japan. And as you can see, depending on the year, down at the bottom, and depending on the location that you choose, the price of this gas can vary significantly. And in my particular case here, I've taken a typical EU gas price over the last 5 or 6 years or so. So my assumption is that the gas costs around 7.5 euros per gigajoule. Plus, I've also included the price of delivering the gas via the natural gas grid, because heat production occurs in the home while electricity production occurs at the power station. So just to consider an important distinction. But anyway, in any case, I think it's really amazing to consider what these results represent, because electricity has only been with us for about 150 years, and we can already produce it at a price of around 40 euros per megawatt hour. However, we've been controlling heat for at least 100,000 years so far, and yet we still spend more money producing a unit of heat than we do producing a unit of electricity, which kind of would say that the heat sector is one of the least innovative sectors in terms of price that we currently have in the world, I would say, because there's very few industries that have been with us for a scale of 100,000 years, and we still haven't reduced the cost that significantly in that time. I would expect, considering how long and how well established the heat sector is, we would be doing it at a much better price than 60 euros per megawatt hour. Just a fun fact to consider. Of course, this might be a hard thing for people to digest, so I just want to take one comparison which I think really highlights how this actually happens. So let's just go through a small story here where we look at this coal-fired power station. This coal-fired power station is 700 megawatts in size, which means it has a total investment of about 1.5 billion euro to spend. Now, of course, people are thinking, how on earth can a plant that costs 1.5 billion euro to build be cheaper than using a boiler? And I need to bring you through a very quick comparison to show you how that actually happens. Because if we assume that a typical house consumes 5 megawatt hours per year of electricity, and we look at the typical production from this coal-fired power station, we can see that this plant would typically provide electricity for about 1.2 million homes each year. So a 700 megawatt coal-fired power plant costs 1.5 billion euro, supplies around 1.2 million homes each year. In comparison, the gas boiler costs a measly 4,000 euro, so it seems really, really cheap. However, sometimes smaller costs can be deceptively big, because although it's only 4,000 euro to install a gas boiler in a home, you have to consider what it would be for the 1.2 million homes that are using to make it equivalent to the electricity example. And if we want to install 4,000 euro boilers in 1.2 million homes, that will actually cost 4.5 billion euro to install. In other words, although one gas boiler seems like it's cheap, when you add up all of the gas boilers we have in the buildings, it's actually really expensive. So using these 1.2 million homes as a common example, the boilers in those 1.2 million homes would be 4.5 billion euro worth of, let's say, production capacity, whereas the coal-fired power station is only 1.5 billion euro of plant that we're actually constructing. Again, I haven't included the electricity grid, so there's maybe some cause for adding more costs on the electricity side, but I think this scale gives you an idea as to why boilers and the heat price can be actually much larger than you might imagine it to be. Because in this case, for these 1.2 million homes, the boilers they require are actually 3 times more expensive than the power plant they require to provide their electricity. And that's just to give you a sense of how important it is to aggregate numbers so that they're comparable and not just compare single investments with one another. Because looking at just the single investments, the boilers here would have seemed tiny in comparison to the coal-fired power station. So why is this all so important to me? Why am I highlighting all of these? Why is it so important to consider the value of the heat sector? And the reason this is so at times frustrating during the discussions of Heat Roadmap Europe is because right now we have such a small value on the heat that we produce. So in many cases around Europe today, we have power stations that produce electricity and simply waste the heat that they produce. In other words, when a power station like this coal-fired power plant produces electricity, the heat it produces at the same time is simply thrown into the nearby sea or river or lake, even though it produces similar amounts of electricity as it does heat. And the fish market is not a very good market to sell your product to because they don't pay very well. So right now that heat, you could say, is being valued at €0 per megawatt hour. And this is happening on an enormous scale. It's not just happening in one plant, it's happening across Europe. So what this graph illustrates is the amount of fuel that goes into the power stations is highlighted in this yellow-green bar here, and the amount of electricity produced by the power stations is in the second column. So the difference between the yellow-green area in the first column and the yellow or green area in the second column is the amount of energy lost during electricity production in Europe today, and that energy is primarily in the form of heat. And if we look at the scale of it, it's around 20 ettajoules, which is around 5,500 terawatt hours. And if we compare that 5,500 terawatt hours of heat that's lost during electricity production with the numbers I displayed earlier, you can see it's a lot more than the heat demand we currently have in all buildings in Europe today, which is around 3,600 terawatt hours. In other words, we lose more heat during electricity production than we actually need to heat all of the buildings. And of course, this represents the maximum amount of heat we could recover during electricity production. So in reality, we probably cannot recover all of that, but simply looking at the scale, we can definitely recover a lot that needs to meet our heat demand in the buildings. Another important thing to consider is that these excess heat can only be used in places that have a district heating system. And a district heating system is something that connects a power station to the buildings using hot water networks. And these power stations can only be connected to buildings that are typically located in the cities. And you can see, for example, this is what a typical power station looks like that sells its heat. And here's a typical picture of the pipes that transfer the hot water from the power station to the buildings. But like I presented in an earlier video, these are only suitable in the city areas where the buildings are located close enough to one another so that the network can be shared. In other words, in the cities, you can build a network at an affordable cost because the buildings are located so close to one another. And what we've analyzed in Heat Roadmap Europe is using our thermal atlas and our modeling work, how much of our heat demand is in these city areas. And we have a lot of work done to establish exactly where these suitable city areas are. And we've found that at least half of the heat demand in Europe is in cities that could actually implement district heating systems, whereas only around 15% of the heat demand today is actually using district heating. So there's a potential to grow it by at least 3 times compared to what it is today. So if we go back to my very rough overview, if we have a maximum amount of recoverable heat from electricity generation of 5,500 terawatt hours, and today we're only covering around 500 terawatt hours, then let's make an assumption that we recover an extra 1000 terawatt hours per year, which would still be much lower than the 50% that I said we could at least can transfer in the cities around Europe. So district heating could be implemented at least to this level, and we have the excess heat available to provide the heat to these district heating systems. What would happen then? Well, in that case, if we recovered an extra 1000 terawatt hours of heat, and if we sold that heat for 30 euros per megawatt hour instead of selling it to the fish market for free, then those power stations would actually earn 30 billion euro a year more in Europe every year. And now, after all of the discussions around the banking crisis and other financial markets, 30 billion euro can be a hard number to relate to and is thrown around quite a lot. So I just want to relate it to something. And if we look at the 60,000 person stadium that Arsenal built in the last about 6 or 7 years ago, that cost around 500 million euro to construct. So 30 billion euro equates to 60,000 seater stadiums each year of extra income. In other words, the power stations would earn enough money each year from a product that they currently throw away to build 60 football stadiums each year. And that's a lot of money that is currently being sold or spent for thrown away for free into the fish market. And this is why we believe in our discussions around Heat Roadmap Europe that the heat sector is being significantly undervalued. Not under-recognized in terms of its demand, but undervalued in terms of its economic footprint. This is starting to change and has changed a lot in countries that have seen the opportunity. For example, there's a new power station in Copenhagen, and I have particularly referred to the word power station because in effect, power stations in countries where there's district heating are no longer really power stations, but instead they're heat stations, because this new power station in Denmark will have a capacity of over 400 megawatts on heat and 150 megawatts of electricity. So in countries with district heating, they've seen the value of the heat sector, and because of that, what used to be called power stations are now actually heat stations that have a byproduct of electricity. So people in countries with district heating are starting to see this value, whereas there's still so many countries in Europe that have not recognized this huge value in the heat market. Another thing is that this is not just about money, but it's also about security of supply. This is just a rough diagram that I got from the Daily Mail in Britain, which demonstrates the dependence we have on Russian gas for our heating right now. And what we could do is, instead of importing natural gas to produce our heating from Russia, we could simply use the waste heat from our power stations to replace this natural gas in our cities. So it's not just about saving money, it's also improving the heat independence in Europe by using a local heat supply rather than importing gas from unreliable sources such as Russia, which can often be cut off if there's a shortage in supply or so on. So in summary, the heat demand is big and that's recognized, but what also needs to be recognized is the heat sector is extremely valuable. Electricity is expensive to produce, but heating is actually in some cases even more expensive. So the idea that heat is a byproduct that should be thrown away needs to stop. We need to stop wasting heat as if it's not very valuable and start recognizing its value. For example, if the power station sold excess heat, they could earn around 30 billion euro per year, which is enough to build 60 large football stadiums each year. And that's a lot of extra money to have in Europe. And it's a way for us to replace our gas imports at the moment. So thank you very much for listening. I hope you got some insights into why we see the heat sector as being such a valuable part of the energy system and how it's so important we start to recognize heat as a valuable commodity. You can find out more on the heatroadmap.eu website, follow us on Twitter at heatroadmapeu, or subscribe to our YouTube channel where you'll find a lot of other more interesting videos. Thanks for listening.